Morning, students. So this class we are going to discuss the continue break statements in the loop. So already we know what is the break statement. Okay. Previously we have seen the break statement in the switch case. Okay. So when the break statement is executed, what happened? The control will transfer to the outside the comes to the outside loop. Okay, that is the next statement of the block. It terminates the statements. Okay, suppose when the case value here, the expression is true, means the case value 1 is evaluated. After that, the break statement unconditionally transferred to the end of the statement. Okay, that is the next statement. Similarly, there is one more statement available, what is called the continue. Okay. So the continuous statement is used to bypass the loop, not break out. Suppose that here, you see this program. So here I am defining I and number as an integer. So in that message, C out, enter a number, C in we read a number. Initially assign I equal to 0. Okay. Then increment this I. Now I equal to 0 means I now becomes 1. Okay. If I mod 2 equal to 0, so I is a 1. So 1 mod 2 equal to 0. So false. False means it comes to else spot. Print I. So 1 will be printed. Then again it comes to the loop. Suppose we read the number n equal to 10. Okay. Then I becomes 1. 1 is less than or equal to 10. So it is true. Then I plus plus. So I becomes now 2. If I mod 2 equal to 0. So 2 mod 2 equal to 0. So true. True means what happened? It continue. Then continue means the remaining statement will not be executes. Then it goes again to the loop. Okay. So 2 will not be prints. Then again it checks. 2 is less than or equal to 10. So true. I plus plus. Now I becomes 3. If I mod 2, so 3 mod 2 equal to 0. So no. So what happened? It comes to the else spot. Therefore, it prints the I. So 1, 3. Okay. The next I is increments. 3 is less than or equal to 10. I plus plus. Therefore, I becomes 4. 4 mod 2 equal to 0. True. Therefore, continue. Continue means again it comes to the loop. So 4 won't be printed. That means only this program prints only the odd numbers, not the even numbers. When it encounters the even number, what happened? The continuous statements will not execute the remaining statement. It goes to the loop. Okay. So this is the use of the continue statement. Break statement here. So when the statements are executed here, when the break encountered, what happened? It come out of the loop. Okay, so that is here. The break statement is executed. It comes to the outside statement, out of loop. Whereas if it is continue, then it won't be come out from outside. Then again it goes for execution the loop. Okay, only bypass the remaining statement in the loop. So that is the difference between break and continue. The next another statement is go to statement, unconditional control. Okay. Previously we see if while these are the conditional, it evaluate a condition, depending on the condition, the branch or loop will be executed. Whereas the go to is a unconditional, there is no condition. Okay. So this is the general syntax of the go to statement. Okay. Here we use the go to as a forward jump or backward jump. Okay. For example, when the program is encountered, go to label. The label is defined by the user, programmer. Okay. So here there are some statements. When this statement is executed, then control will transfer to the label. Then after that, the statements will be executed. These statements are not executed. Okay. So this is a forward jump. And in the backward jump, so label is defined here. Then statements are there. Then go to label. Then control immediately unconditionally transferred to the label. Okay, again the statements are executed, then go to label, then control will transfer to label. Okay, so this is the use of the go to statement. Okay. So unconditional transfer of control is used by the go to statement. Okay. Let me see some programming examples. So go to. Okay, here is a simple example for the go to statement. If your age is 18 and above, you are eligible to vote. Otherwise, you are not eligible to vote. Okay. Here, ineligible is a label defined by the programmer. So here just initially we print you are not eligible to vote. Then here see out, enter your age. So this is the message. Enter your age. Then I'm defining the age as an integer. Then read that age by using the cin statement. If age is less than 18, so you are not eligible. Okay, therefore go to ineligible. So label, go to label. So it comes here. Right. Suppose if the age is greater than or equal to 18, then you are eligible for vote. If you run this program, enter your age 19. So you are eligible to vote. 50. You are not eligible to vote. Okay. So this is the use of the go to state. Okay. Here we use the jump from here to here. So that is the forward jump. Okay. Here one simple example. So already I have explained this program. Use of the continue statement. Okay. Right. So let me take some 50 numbers. Okay. So I ranges from 1 to 50. So if I mod 2 equal to 0 means continue. So two errors are generated. Okay. For this one, no, right. Now execute this one. Oh, you see that. So when the numbers are even, then we use the continuous statement. That is, that number won't be printed. If the numbers are odd means the else part will be executed. Then it prints. Okay, 1357 like that. 49. So we generate the odd numbers between 1 and 50 using the continue statements. Then next program is here. So palindrome, not a string. Here the number. A number is a palindrome or not. Okay. So this palindrome logic is similar to sum of digit logic. Okay. Here I am defining n or some temp as an integer. Then we read a number n. I am assigning n to temp. Okay, the temporary number consists of n because we want to check the number. Now, while n is greater than 0. Okay, suppose you are entering to two-digit number 22, right? Then n is greater than 0. True. True means r equal to n mod 10. 22 mod 10 equal to 2. Then sum equal to r plus 2 plus sum into r. So 2 into 10. Okay. So 20. Then n equal to n mod 10. What happens? N becomes 22 divided by 2, 10. It is 2.2. It takes the integer part 2. Okay. Then again it comes here. N is greater than 0. 2 is greater than 0. Therefore, r equal to n mod 10. Okay. Therefore, 0. Then already sum equal to 20. Then plus r equal to 2. So 22. Then 22 is already stored in the 10. Here we check 22 equal to sum. So already temp equal to 22 and the sum is 22. Therefore, the number is a palindrome. Otherwise, what happens? It is not a palindrome. Let me execute this program. We enter a number. So 1, 2, 1. When palindrome means when we reverse this number, so 1 again 2, 1. The same when we reverse a number, the number also becomes the same means it is a palindrome. Now 121 is a palindrome. It is a palindrome. Suppose that. So 123. When we reverse this number, this becomes 321. So this number is not a palindrome. Okay. The number is not a palindrome. So that this logic is similar to sum of digit. Okay. Is it? The sum of digit. The same logic is applied here in order to check palindrome. Execute another number. Suppose 1, 2, 3, 4, 5. So this number is not a palindrome. Then execute another one. So reverse this. So the number is a palindrome. Okay. Similarly, we can also find a given string. It's a palindrome or not. If we see that program later. That is, for example, madam. You reverse the madam, then again the meaning is the same. So what is called a palindrome. So we have already seen the prime number, then sum of digit, What is the use of the continue statements? So this is the while. Okay. Then go to so this is the go to program. So those statements already we have seen. Okay. Then Armstrong. So Armstrong number. Armstrong number. So this program let me see in the next class. Okay. Thank you, student.